In order to talk about division of fractions, we first need to understand a concept we have not yet mentioned, which is the reciprocal of a fraction. Reciprocal fractions are just the upside down version of the original fraction. What does it mean? Let's view that. It's always easier when we can see it. Let's make two columns, one with the original fraction, one with the reciprocal. Let's say that the original fraction is 5/8. To get the reciprocal of this fraction, all we need to do is the denominator, which is 8, is going to be moved to the numerator. So 8 goes to the top. And the numerator, which is 5, is going to be moved to the denominator. So the reciprocal of 5/8 is 8/5. It's just the upside down version of it. Let's do it one more time. 15/22. 22 is the denominator, so we move it up to the numerator. And 15 is the numerator, so we move it down to the denominator. So the reciprocal of 15/22 is 22/15. But we can also get the reciprocal of numbers, not just of fractions. For example, the reciprocal of 5 is we put a 1 in the numerator and we move the 5 to the denominator. And that's how we get the reciprocal of regular numbers. Let's do 15. We write 1 as the numerator and move 15 as the denominator. And this is how we get reciprocals of fractions and numbers. But why are we talking about reciprocals? It's because one of the methods to solve for division of fractions involves using reciprocals. Let's see it. Let's say we have 3/4 divided by 7/5. What do we do in this situation? We take the first fraction and we're going to copy it as it is. We leave it as it is, 3/4. The second fraction, here is the trick. For the second fraction, we must get the reciprocal. This is why it's called the reciprocal method. Instead of writing 7/5, we write 5/7. And very important, the division now changed to a multiplication. So 3/4 divided by 7/5 is the same as 3/4 multiplied times 5/7. And after that is a multiplication of fractions. Multiply the numerators together, and multiply the denominators together. Remember, we learned this in lesson 1.2, so you can review this lesson if you want to refreshing your knowledge. And then 3 times 5 is 15, 4 times 7 is 28. This is the answer to our division of fractions. Let's do it one more time. 12/15 divided by 3/2. So we copy the first fraction. That 12/15 stays as it is, 12/15. The 3/2, that's the second fraction. We have to get the reciprocal, so 2/3, and change the division to a multiplication. 12/15 divided by 3/2 is the same as 12/15 multiplied times 2/3. Okay, multiplication of fractions. Copy the numerators, copy the denominators. One more time. This is lesson 1.2 if you want to review it. 12 times 2 is 14. 15 times 3 is 45. This is the reciprocal method. This is how we solve division of fractions. But one more time, math is not always straightforward. Sometimes our fractions are not arranged like that. Sometimes our division of fractions are arranged like this, because remember, divisions can always, every single time be rewritten as fractions. What do we do in this situation? It's actually the same thing. The first fraction, the 3/4, we write it as it is, 3/4. The second fraction, 7/5, we must get the reciprocal of 7/5. And after that is a multiplication. 3 times 5, 4 times 7. We reviewed this in lesson 1.2. This is 15/28. There is another way to do this type of divisions when they are one on top of the other, when the fraction looks like this. And it's called the double C method. It's called the double C because we make a couple of C's to solve. It's a fraction, and the first C is a small c, connecting those two middle numbers. That small c is a multiplication, and it goes in the denominator. Then we write a big C, multiplying the top number, top and bottom numbers, the outside numbers, and they go in the numerator. It's called the double C because we have two C's. The small c goes in the numerator, so 4 times 7, and the big C goes in the numerator, so 3 times 5. Do the multiplications, and we get 15 over 28, and this is how we do divisions with the double C method. For more math lessons like this one, visit our website, mathusermanual.com, or follow us on Instagram at mathusermanual.